And here we are in the final video for section 3.1, and we are still continuing talking about functions and the introductory part to it, basically. And realize that we can add, we can multiply, subtract, and divide two functions. However, once we do that, we may end up with a different domain than what the original function started out with. And so that's where we are here at this particular stage. We're looking at example number 13. We are told f of x is equal to 3x plus 4. And g of x is equal to 4x minus 6. And we are specifically asked, what is f times g? Well, that simply means take this and multiply by this. And whenever you are putting these in, get into the habit of putting the whole function inside a set of parentheses, because that will play havoc with some of you. Realize what we have to do here now is to FOIL this out, and so we get 12x squared minus 2x minus 24. And that's after we've combined the two middle terms. Now we look at this one, there's no restrictions, there's no square roots, there are no fractions, and so the domain would be all real numbers, which we show in this manner. We go anywhere from negative infinity all the way up to positive infinity. Example number 14. We have f of x equals 5x cubed plus 3. G of x is equal to 5x squared minus 3, and we are asked what is f times g. Now it just so happens we've got two multiplication problems. We can add, subtract, multiply, and divide. It really does not matter here. And once again, I'm going to remain in the habit of, once we're doing these operations, I'm putting the entire function inside a set of parentheses so that I don't forget to do something important. For example, FOIL. If I don't FOIL, I'm going to get the entirely wrong answer. And so, multiplying this out, we're going to get 25x to the 5th minus, let's try 15, not 13, minus 15x cubed plus 15x squared minus 9. And what we look at here is the fact that nowhere do we have any restrictions. This one, all real numbers, this one's all real numbers, and our combined function is all real numbers. And if at any time we had to restrict something, we had to take that into consideration, not only in the original functions, but also the combined one, like we have here. Example 15, we have f of x equals the square root of x plus 11, and that should be a red flag. We've got square root, so we are going to have some sort of a domain restriction. And g of x is equal to 2 over x. Okay, that should be another red flag because we have a fraction, so we're going to have some sort of a restriction. And then we are asked, what is f times g? So f times g will simply be f is the square root of x plus 11 times 2 over x, which this is just a matter of cleaning it up just a little. 2 times the square root of x plus 11 all over x. Now some of the restrictions that we know, x equaling 0 does not work, because then this would have 0 in the denominator. Likewise, we know x plus 11 has to be greater than or equal to 0. It's okay to have the square root of 0, but we can't have square root of negative numbers. And so this becomes x has to be greater than or equal to negative 11. And so we know the absolute smallest number we can have is negative 11. Now, can we include this? The answer is yes. So we're going to have that as a bracket, and we can go all the way up until the value of 0, but not quite 0. Then we can immediately start with the value of 0 again and go on forever. We'll never run into another problem. We've already found the problems. When that equals 0, and when x plus 11 was less than 0. That was the problem. And so here is the final function, and here is the domain in that form. The last two problems are word problems, and so we can just deal with what they have. It says find f minus g of 4 when f of x is equal to negative 3x squared plus 2 and g of x is equal to x plus 6. Now there's really two ways to do this exact same problem. We could find f of 4 and g of 4 and do the subtraction, or we can just take f of x minus g of x and whatever that value is, plug in 4. So I'm going to do it the second way, although the first way is actually a little bit easier, but you'll see this really isn't too terribly difficult. F minus g would be, once again, negative 3x squared plus 2. I'm putting that inside a set of parentheses, minus x plus 6 inside a set of parentheses, and this equals negative 3x squared minus x minus 4 when it's all simplified and everything. And so now all we have to do is find out what is f minus g of 4. Well, that simply means plug in 4 in for x everywhere. So negative 3 times 4 squared minus 4 minus 4 equals 3 times 16 minus 4 minus 4. 3 times 16 is 48. 48 minus 4 is equal to 40. Now realize we could have done this, like I said, we could have plugged in 4 in for f. Plugging in 4, we get negative 3 times 16 plus 2. Well, negative 3 times 16 is negative 48. Negative 48 plus 2 is I messed up. This needs to be negative, and this needs to be negative. So our final answer would then be negative 56. Okay, now coming back up here for this other way, plug in 4 here. Negative 3 times 16 is negative 48. Negative 48 plus 2 is negative 46. And then 4 plus 6 is 10. Negative 46 minus 10 is negative 56 as well. So you see, it works either way. And the final example for this particular group is example number 17. It seems to be a fairly lengthy problem, but I think you'll see that it's not all that terribly bad. A firm is considering a new product, and we get that the total cost, C of x, is equal to 65x plus 4,430. The sales department determines that the revenue will be 75x. So in other words, we're going to, well, okay, never mind. I'm trying to get ahead a little bit. Each one of these represents how many units they're going to sell, whether they're coats or animals or what, I don't know. But we cannot do more than 731 units can be sold at this price. It cannot be sold at this 75. So we are asked to find what is R minus C of X, no, of 731 And we are asked to interpret that. Well, the calculation in and of itself isn't all that bad. R minus C would be 75x minus 65x plus 4,430, which equals 10x minus 4,430. And then we can substitute in the 731 in for x, and so we get 7,310 minus 4,430, which equals 2,880. Now that's what it equals. Now the question becomes, what does it mean? What is the interpretation of it? Well, R represents the revenue, how much money we're bringing in. C represents the cost, how much we're sending out. So what this would amount to is we would have a profit of $2,880. That's take-home profit, I guess, is the best way to say it.